In this session, I'll be covering the topic called internal combustion engines emission control technologies. So my name is P.Arjunraj. I am a technical innovation and VAVE consultant. I am also the education committee member in Miles Valley Foundation USA, and I am also the South Zone Council member in Indian Value Engineering Society, India, and I am a member in SAVE International USA. I can be contacted at p.arjunraj@gmail.com. So the challenges what we have with respect to the internal combustion engine, we have basically two types of engine. One is a diesel engine, another one is a gasoline engine. In the case of diesel engine, we have the challenges of the trade-off emission between nitrogen oxide emission and particulate matter emission. When nitrogen oxide emission is lesser, the particulate matter emission will be higher, and vice versa. So reducing the two terminologies, the nitrogen oxide emission and particulate matter emission, is the most challenging task in the case of a diesel engine. And again, the next important thing is the goals of reducing the fuel consumption and emission together. If you're trying to reduce the fuel consumption, the emission will be higher, and vice versa again here. So this is the second challenge that we have in the case of a diesel engine. And the third challenge is the smoke and the particulate matters. So we have the smoke and also the particulate matter in the case of a diesel engine. And of course, the last important thing is the vibration and noise. Vibration and noise are also higher in the case of diesel engine. And in the case of a gasoline engine, you have only two challenges. One is the CO2, which is nothing but a fuel efficiency. And the second challenge is the lower speed torque. We will see the combustion in SA engine and the CA engine, because we will get the emission only after combustion. Okay, so combustion is the root cause for the engine to get power and also to get the emission. So what happens in the case of SA engine? When you ignite the fuel, the combustion will take place, which means when you ignite the fuel, in fraction of second, in fraction of time, what happens is that the pressure gets footed up and the combustion starts. So once the combustion starts, the pressure gets footed up. You have three type of combustion process in the case of SA engine. One is a normal combustion process, where the ignition will happen at the correct position. And the other two type of system is over advanced system, and another one is the retarded system. So what happens when you're when you're advancing the ignition? Okay, it's better to advance, but when you're doing over advance, what happens is that your pressure shoots up to the higher level than the normal, and you get the abnormal pressure, which will result in the abnormal sound, which is nothing but a knocking sound, and there is a possibility that your engine might go for a failure. And what happens to the third system called a retarded system? So when you are igniting the fuel, in the case of SA engine, which is nothing but a gasoline engine, so here when you are retarding the ignition, you get the lesser power, which means you are going to get lesser torque. When you are getting the lesser torque, then you obviously your power also will get reduced. So the challenging thing in the case of a combustion with respect to the SA engine is that to have a normal combustion process throughout the cycle. we should avoid both over-advancing system and also retarding system. And we have the important combustion process in the case of a diesel engine, which is nothing but a CA engine. So here in the case of CA engine, there are 4 stages where the combustion will take place. The first stage is nothing but the ignition delay period, and the second stage is nothing but a pre-mixed combustion phase, and the third stage is nothing but mixing controlled combustion phase, and the last phase is nothing but a late combustion phase or a dead phase. So what happens here is the first phase is nothing but the ignition delay period, where you start injecting the fuel and you have the gap or delay for the combustion to take place, and that period is nothing but the ignition delay period. It's also called the injection delay period, because in the case of C engine it is called injection, and in the case of S engine it is called ignition. And the second phase is nothing but the pre-mixed combustion phase, where air and fuel will get pre-mixed and the combustion will take place. And the third stage, important stage, is the mixing controlled combustion phase, where air and fuel gets completely mixed up, and you go for the end of injection phase. Once you stop injecting, then your rate of heat release goes down, your pressure goes down, and you come to the late combustion phase, which is nothing but a dead phase, where your torque comes down, power comes down, and your rate of heat release comes down, and also your the combustion pressure will come down. And these are the 4 stages of combustion in the case of a diesel engine. Let us see the emission sources of the conventional engine of both gasoline and diesel. In the case of a gasoline engine or SA engine, you have carbon monoxide, hydrocarbon, and nitrogen oxide emission. Whereas in the case of CA engine, you have extra one pollution called particulate matter pollution or particulate matter emission. So in the case of CA engine, you have carbon monoxide, hydrocarbon, NOx, and also the particulate matter. So the extra one enemy is being added in the case of CA engine. Whereas in the case of SA engine, you have carbon monoxide, hydrocarbon, and NOx. So these are the emissions which are normally coming out of the vehicle, which includes carbon monoxide, hydrocarbon, NOx, and the smoke. And the particulate matter is common in the CA engines. So basically, we can reduce the emissions with the help of after treatment technology in the case of diesel engine. In the case of gasoline engine, we can reduce carbon monoxide, hydrocarbon, and particulate matter. There is no particulate matter in the case of gasoline. We have NOx. So NOx, hydrocarbon, and CO can be reduced with the help of a 3-way catalytic converter in the case of a gasoline engine. Whereas in the case of diesel engine, we need to go for after treatment technologies. Let us see what are all the different type of after treatment technologies that we have in the case of a diesel engine. The first after treatment technology is oxidation catalyst, and the second after treatment technology is DPF, and the third technology is SCR or selective catalytic reduction catalyst. So when you're going for an oxidation catalyst, you can reduce the carbon monoxide and hydrocarbon. When you're going for a DPF or a diesel particulate filter, you can reduce the particulate matter emission or carbon soot particle emission. And when you're going for a SCR catalytic converter or selective catalytic reduction catalyst, so when you're going for this technology, you can reduce the nitrogen oxide emission, where you inject ammonia, which is nothing but NH3. So NH3 will react with NOx, NO2. So you get N2 plus water. So both nitrogen and water are harmless. And you also get CO2 out of the tailpipe emission. You can reduce the CO2 only if you reduce the CO, which is coming out of the engine. So you can reduce the CO by going for a better combustion process, by going for a complete combustion. Incomplete combustion should be avoided. So this is the complete architecture of a after treatment technology in the case of a diesel engine. As I said, first is DOC or diesel oxidation catalyst, where you eliminate, it will reduce the carbon monoxide and hydrocarbon emission. And you go for a next treatment called a diesel particulate filter, where it will eliminate the particulate matter emission or a carbon soot particle. So it is completely operated with the help of the engine control unit, electronic control unit. It consists of sensors, actuators, and closed area network. And the important thing is that SCR catalyst, which is the important after treatment technology, which will reduce or which will reduce the nitrogen oxide emission. So you inject ammonia, which is nothing but a urea, which is nothing but NH3. So NH3 will react with NO2 and you get nitrogen and water, which is coming out of the tailpipe emission. When I say it's a SCR catalyst, you have the urea tank and you have the injector to inject the urea. And you also have the control unit to control the amount of injection. You have the line which supplies the urea from the tank to the system. So it's a complete system which is like the fuel injection system. Fuel injection system consists of a fuel tank, fuel pump, and the fuel injection system. So it's similar to that. This urea injection system having the urea tank, urea supply line, and urea injection module system. And finally, as I said, this ammonia, when it is reacting with nitrogen oxide, you get nitrogen and water, which is nothing but H2O. And you also measure the NOx, which is coming out of the SCR. Reducing the emission is very important because carbon monoxide, hydrocarbon, NOx, particulate matter, and the smoke, all this will lead to the health hazards to the human beings, and also it will affect the plants, which we are also taking in for our food, which is giving us the nutrition. So in fact, again, we will also get disturbed if the plant is getting disturbed because of this emission and pollution, which is coming out of the automotive vehicle. And the source of the emission from the automotive vehicle is the engine. Okay, so we need to use the multiple injection strategies. We need to analyze, not only we can use, but we also need to analyze the multiple injection strategies where we can look for reducing the carbon monoxide, hydrocarbon, and the NOx and particulate matter, and how we can reduce the smoke. We need to go for a systematic analysis using the multiple injection strategies. As you know, we will get higher noise when the engine is running in low idle RPM. And when the engine is running in rated power, we get the maximum power. And we get the particulate matter emission and also the nitrogen oxide emission when the engine is running at higher RPM and also when the engine is running at idle RPM. And you also have the torque consumption, which will vary with respect to the engine speed and also engine load. And this is the characteristic curve of a torque with respect to the speed of the engine. So we need to understand the power, torque, the speed, NOx, noise, and the particulate matter emission, the torque consumption. All these strategies we need to understand while we're going for a multiple injection strategies. So what happens in the case of multiple injection strategy? What's the advantage is that, as I said initially, when you are trying to reduce the nitrogen oxide emission, your particulate matter emission will be higher. When you are reducing the particulate matter emission or a carbon soot particle, your NOx emission will be higher. So trade-off between the soot particle and the NOx is the most challenging one. And similarly, reducing the BSFC and reducing the carbon monoxide and hydrocarbon is also the challenging task. So in order to balance all the parameters, which includes combustion noise, nitrogen oxide emission, hydrocarbon, carbon monoxide, PSFC, soot. In order to balance all these parameters, you need to go for a multiple injection strategies. And you can go for a multiple injection strategies in various methods. The fuel injection starts 20 degrees before TDC. So what you can do is that instead of going for a 20 degrees before TDC, what you can do is that you can inject a fuel in different stages, not only in a single stage. You can give some gap. For example, you can inject the fuel with some quantity and you can give some delay period, and again you can inject the remaining quantity of fuel. So what happens when you are giving the delay period or when you are giving some time to inject the next quantity of the fuel? So when you're giving the delay period, the temperature, your peak temperature comes down and your NOx emission comes down. Okay. And when your nitrogen oxide emission is coming down, you're also ensuring that you're not going to compromise on the soot particle, because obviously, as I said, when you're reducing the nitrogen oxide emission, your carbon soot particle will be higher. And you need to select the best combination of going for a different type of percentage of fuel injection out of 100%. So either you can go for a pilot, which means small amount of first injection, and then you can inject after some time. Remaining 80% you can inject, and the next stage maybe 15% we can inject at the first time, and remaining 85% you can inject after some delay period. And similarly, you can go with different combination like pre plus main plus after, which you can go with either different combination of percentage. It can be 15 or it can be 20 or it can be maximum of 50. So you need to select the best combination in order to get the best combustion noise, best NOx, best hydrocarbon, best carbon monoxide, best BSFC, and best soot particle. And this strategy will help to reduce the carbon monoxide even before going for after treatment technologies. And when you're going for after treatment technologies, still the carbon monoxide, hydrocarbon, and NOx can be reduced to the further extent. And obviously, you will get CO2, which is coming out of the final engine tailpipe. So you can reduce the CO2 only if you reduce the CO, which is coming from the first stage itself. So it is always better to go for a multiple injection strategies to have a better amount of optimized emission, and also to ensure that we are going with the correct amount of emissions, which will meet the emission standards and also norms. And when you're going for a multiple injection strategies, so you have a lot of bottlenecks as well. So you have different parameters, which includes main injection advancing the main injection. So when you are going for a main injection advance, you will get lesser carbon monoxide and hydrocarbon, but you will get higher noise. You also get better fuel consumption, which means your mileage will be better. But your NOx and the particulate matter will be higher. And again, when you're going for a pilot injection, which means when you're going for a pilot quantity increase, your NOx will not get affected and your fuel consumption will not get affected, but you will get reduced carbon monoxide and hydrocarbon, and you will also get higher particulate matter, and you will get lesser noise. And what happens is when you're going for the rail pressure increase, this is a very important parameter. When you're going for a rail pressure increase, you will get lesser particulate matter emission and you get higher NOx, and obviously your noise will also be higher. And when you're going for a boost pressure increase, when you're increasing the boost pressure of the engine, your particulate matter emission will be lesser. And when you're going for a EGR application, when you're going for exhaust gas recirculation application, your nitrogen oxide emission will be lesser. because your nitrogen oxide emission will be lesser, because then when you're going for a exhaust gas person, you are increasing the, the your peak pressure, your peak temperature comes down. You are going to diffuse the oxygen content in the air, thereby your nitrogen oxide emission goes down. When you are reducing the nitrogen oxide emission, obviously your particulate matter will be also higher. We will see how the exhaust gas recirculation basically operates. So this is the EGR system. So we start with the Euro 4 engine, which is nothing but the Euro 4 is nothing but the BS4 engine, what we call in India. So when you're going for a BS4, you might be knowing BS2 and BS3. So what is the difference between BS2, BS3 and BS4? So in the case of BS4, you have the EGR valve and EGR cooler. And what happens when you're going for a EGR cooler is that your exhaust gas again is recirculated to the intake manifold. And as I said, when the exhaust gas is recirculated to the intake manifold, your oxygen content will get diffused in the air, and your peak temperature goes down and nitrogen oxide emission goes down. So this BS4, it's in India it's called BS4, and in Europe it is called Euro 4, and it also has DOC DPF, which I explained already to you. DOC will reduce the carbon monoxide and hydrocarbon, and DPF will reduce the particulate matter emission. So this is the normal engine configuration where it is having the turbocharger, having the turbine in one end, and it's having the compressor in another end. And you have the intercooler to increase the volumetric efficiency of the engine. So in the case of Euro 5, what happens is the system remains same, except you have one bypass valve, because when the temperature is higher, in the exhaust gas temperature is higher, this bypass valve will not allow directly the exhaust gas to go to the intake manifold, wherein again it goes to the system, again it gets recirculated, and again it gets cooled, and again it goes to the intake manifold. There is no difference between Euro 4 and Euro 5. And we are not going with BS5 in India from BS4. We are directly going with BS4 to BS6, which already implemented in the year 2020. Current year in April 2020, they implemented Euro 6. But we have not gone with Euro 5 or BS5 technology, where the change is only with respect to the bypass valve. So here we use high pressure EGR valve or EGR module along with the cooler and along with bypass valve. This is the only difference is only you add bypass valve in the case of Euro 5 when compared to the Euro 4. So the next important thing is Euro 6. So in India we call BS6, Bharat stage 6. So in the case of EGR system, basically the Euro 6 system, what we have is we have high pressure EGR valve and EGR cooler, and you also have the SCR technology or LNT. SCR is nothing but selective catalytic reduction technology, and LNT is nothing but clean NOx trap to reduce the nitrogen oxide emission. And again, further to reduce the nitrogen oxide emission, you also have the low pressure EGR cooler and low pressure EGR valve to reduce the nitrogen oxide emission still to a greater extent. And the DOC DPF remains same. And the important thing between BS4 to BS6 is to reduce COHC and also NOx. The amount of NOx getting reduced is too high. So that's why you need to have the SCR, LNT, and also some of the vehicle is having the low pressure EGR valve and EGR cooler. Most of the Ashok Leyland vehicle using this technology, but since it's costly, people are not going with this low pressure EGR cooler and low pressure EGR valve. But still, if you use this, still your NOx emission can be still much more reduced to the greater extent. So this is how the complete EGR system looks. This is the example of a 4-cylinder engine. So the air coming from the atmosphere is made to go inside the intake manifold. So you have the throttle body that allows the amount of air and the exhaust gas which is coming to the intake manifold. You have the exhaust gas recirculation mixer, and the shape of the intake manifold can be it should be the convergent divergent nozzle type, so that you get the correct amount of air and gas is entering with required amount of velocity and also the pressure. So this is how the complete EGR system configuration looks. And this exhaust gas recirculation is very much essential and important to reduce the nitrogen oxide emission. So in the case of gasoline engine, we use the technology called the catalytic converter technology. This is the only one after treatment technology we use in the case of gasoline engine. Whereas in the case of diesel engine, we use DOC, DPF, SCR or LNT. And we use only one technology called catalytic converter. It is very much efficient to reduce carbon monoxide, hydrocarbon and NOx in the case of a gasoline engine. So how the structure of the catalytic converter looks? It is having the honeycomb catalyst structure, and it is highly insulated. It's also having the insulation cover. It is highly insulated with sealed. It's also having the catalyst. It is completely housed, completely protected. It is also having the mat over the catalyst, and it is having the substrate. And the catalyst, what is being used for the case of catalytic converter is platinum or palladium or rhodium. So you should also ensure that the presence of lead and sulfur in the exhaust gas is not there in the case of a gasoline engine, because when lead and sulfur is present in the exhaust gas, then the efficiency of conversion of carbon monoxide, hydrocarbon and NOx will not be good in the case of a catalytic converter. And this will act as a poison. The presence of lead and sulfur will act as a poison, and your the efficiency of catalytic converter will be reduced. So hence it is necessary to ensure that presence of lead and sulfur in the exhaust gas is not there. So we have seen the diesel oxidation catalyst, which is nothing but DOC. It is the first operation in the case of the diesel particulate condition. So here the DOC, what it will do is that it will reduce the carbon monoxide and hydrocarbon. So it is having the catalyst inside it. You see, is the entry of the exhaust gas coming from the exhaust system, and inside it is having the monolithic structure, mounting material with heat shield, and also it is having the catalyst in it. And when the exhaust gas which is coming in and when it is going out, the CO gets converted to CO2 and HC gets converted to H2O. And this is the example of a diesel oxidation catalyst, the DOC we got. And similarly, in the case of three-way catalytic converter, so we have the similar kind of catalyst, which can be either platinum, palladium, or rhodium, which are being used in three-way catalytic converter to reduce carbon monoxide, hydrocarbon, and NOx in the case of a gasoline engine. And you have COC, which is nothing but the catalytic oxidation catalyst, which means COC is mostly used in the case of diesel oxidation catalyst. So the platinum and palladium is the active material which are being used in the case of diesel oxidation catalyst to reduce carbon monoxide and hydrocarbon. So you have the different catalyst that you need to use for different application. So when you're going for a three-way catalytic converter, you need to use platinum, palladium, and rhodium, because platinum will reduce is good for reducing the hydrocarbon emission, and palladium is good for reducing the carbon monoxide emission, and rhodium is good for reducing the nitrogen oxide emission. And when you're using one particular catalyst alone, say for example, if you're using platinum alone, you cannot reduce the NOx emission. And when you're going for a palladium alone, you cannot reduce the NOx emission. Okay, and when you're going for this rhodium alone, so it is having good. You can reduce NOx and you can reduce CO, but you cannot reduce HC. So hence you need to go for a correct requirement of platinum, palladium, and rhodium. So you need to select the best catalyst based upon your need and want. So this is the effect of air fuel mixer composition. So air fuel ratio is taken in the x-axis and catalyst efficiency is taken in y-axis. So you have three type of mode. One is lean mode, rich mode, and the stoichiometric mode. When your engine is operating in lean mode, which means you are running the engine in higher air mode with less fuel, and the rich mode is nothing but less air and more fuel, and the stoichiometric ratio is nothing but the correct amount of air fuel ratio. When you're going for a catalytic converter, the efficiency is much more better. In the case of rich, when the engine is running in a rich mixer, the efficiency conversion, the nitrogen oxide efficiency is much more higher. And when the engine is running in lean mixture, the efficiency of carbon monoxide and hydrocarbon is much more higher. In this graph, we can see that the nitrogen oxide emission is much more higher in terms of efficiency conversion using the three-way catalytic converter. In the case of a gasoline engine, you can see almost 95% efficiency is there. And when we're going for a hydrocarbon and carbon monoxide, the efficiency is also better, 95 to 98% when the engine is running in lean mode. So lean mode is the one where you have too much amount of air and less fuel, and rich mixture is the one you have too much of fuel and you have less air. So stoichiometric is the one you have correct amount of air fuel mixture basically. So we'll go with the diesel particulate filter. So in the case of a gasoline engine, we can use only the three-way catalytic converter to reduce the carbon monoxide, hydrocarbon, and NOx. The reason behind that is as the engine is running most of the time in a lean mixture, it is easier in the case of a gasoline engine to go with only one technology and you can meet the emission. Whereas in the case of diesel engine, you have a richer mixture or you have more fuel and less air. So which is one of the reason that you need to go with the after treatment because you get a lot of incomplete combustion as well in the case of diesel engine, which is highly impossible only with the help of in-cylinder combustion technology alone in the case of diesel engine. So the first thing what we are going the after treatment in the case of diesel engine is TOC, which is nothing but diesel oxidation catalyst. We have seen that along with the three-way catalytic converter. And next is the DPF, which is nothing but diesel particulate filter. Diesel particulate filter is also called as CSF, which is nothing but catalyzed soot filter. So DPF is also called as CSF, catalyzed soot filter. Okay, so this will reduce the particulate matter emission, or you can also say it will reduce the carbon soot particle. So this DPF or a device that traps the solid carbon particles, preventing it from releasing to the atmosphere. And these diesel particulate filters are effective in controlling the soot. These diesel particulate filters accumulate particulates which could cause high pressure drop across the filter. So you have two type of diesel particulate filter basically. So the exhaust gas which is coming out from the tailpipe passes through the diesel oxidation catalyst, and the exhaust gas which is coming out of the DOC will have the particulate matter emission and also nitrogen oxide emission. So what happens when you're going for a DPF technology? You have two type of method. One is valve flow method, another one is flow through method. So the exhaust gas which is coming out of the DOC will strike the wall and it gets scattered and it comes comes out of the DPF. And when you're going for a flow through method or flow through type, there will not be any scattering of the exhaust gas. The flow is very uniform, and when it is coming out, your particulate matter emission comes down. The level of particulate matter or the group carbon soup particle comes down in both flow through method and also valve flow method. So basically, the flow through is much more. Mostly they prefer because uh, we do not know the efficiency of the scattering technology. But when you're going for a flow through, so you go for the uniform structure, uh, and your efficiency is also much more better. And moreover, you don't need to worry the loss of the efficiency because of the scattering. However, there is no theory stating that, or no research stating that flow through is much more better than valve flow, and valve flow is not highly efficient. Both are comparable, but for the simpler design, flow through is much more better with respect to the efficiency as well. It's also good. And we have the DPF system, which looks like this. Uh, the diesel particulate filter, the design should be much good for sufficient lifetime. It should have low exhaust back pressure, and it should be highly robust regarding the thermal stress. It should have high regeneration performance as well. So when you're going for a target substrate, so it should have a big ash storage volume, it should have high conductivity, it should have high heat capacity, it should have low flow resistance. So when you're going for the material of the diesel particle filter, it should have it should be made up of either silicon carbide or coherite, and the wash coating should be much more effective. It should have the optimum level of valve thickness, and you should also ensure that the porosity level and the cell density is much more better in the case of the DPF filter. So when you're going for the wall flow filter, or when you're going for a flow through method, so you need to ensure that the density is very much important. The cell density is very much important because this cell density will also contribute to the overall weight of the system. So you need to select the density to the optimize the design of length and the thickness. So when you're going for higher length and higher thickness, your cell density will be much more bigger in size, which will add extra weight. And not only the weight, your cost also goes higher because you need to provide the sufficient amount of catalyst to the sufficient volume what you have. So when you're having lesser volume, you can have lesser catalyst. So you have two type of system basically in DPF. One is underfloor system, another one is closed coupled system. In the case of underfloor system, the oxidation catalyst and the diesel particulate filter is having some distance. In the case of closed coupled system, both the oxidation catalyst and the particulate filter are coupled together. So you have the fuel burn additive system. You have three type of particulate filter, diesel particulate filter. One is fuel burn additive system, coated DPF and bad DPF. In the case of fuel burn additive system, you also have the additive dosing unit. And in the case of coated DPF, you have the mainstream solution. And this bad DPF is mostly used for higher application, higher temperature application. So you should also ensure that your regeneration temperature should be 450 degrees Celsius So when you're going for the fuel burn additive system, so when the temperature is lesser, you can go with this type. When the temperature is 600 degree, you can go with coated DPF. When the temperature is beyond 600 degrees Celsius, you can go with the bare DPF. So you have the nitrogen oxide emission after treatment technology. So you use NOx storage catalyst before DPF. So you can also go for this NOx storage catalyst where it is having the catalyst which will store the NOx, and this will eliminate the nitrogen oxide emission as well. Either you can go with NSC plus DPF combination, or the regular combination which includes DOC plus DPF plus SCR. This is how the substrate looks. Okay, this is the cell and this is a substrate, and this substrate is having the uh, structure which is a metallic one, which is having the thickness of 40 to 50 micron. It is also having the wasp coat. So here is this is the wasp coat having the thickness ranging between 20 to 30 micron, and the metallic substrate is the one which ranges between 40 to 50 micron of thickness, and the C is nothing but the catalyst includes platinum, palladium, and rhodium, which is indicated in the black color, and the yellow color is the metallic substrate, and the light blue is nothing but the wasp coat. So we go with the SCR system, the third important system after in the case of after treatment technology. So when you're going for this SCR technology, uh, you are injecting the urea or NH3. So here you need to have the aqueous urea solution tank for reducing the NOx reduction. And you also need to have the separate mixer for uniform distribution of urea into the catalyst. So here you use catalyst like metallic zeolites and vanadium oxide as a catalyst. In the case of Vascoat, you use V2O5 and metallic zeolites. So the overall system efficiency of this SCR system is between 95 to 98 percentage, and you get higher NOx conversion between 220 to 450 degrees Celsius of the catalyst temperature. So if your system temperature is between 220 to 450 degree, you can go with this SCR where you get higher NOx emission conversion. So when you're going for this SCR technology, uh, so the nitrogen oxide emission will be converted to nitrogen and water with the help of oxidation and reduction. So in the case of oxidation, NO will react with the oxygen, so you get NO2, and this NO2 again in the case of reduction, it will react with it will react with ammonia, and you get nitrogen plus water, which are harmless. So you also undergo thermolysis, hydrolysis process here. This is the complete system of the architecture which I explained already. And this selective catalytic reduction control system, it basically having the urea tank. And so designing this is also very much important. You need to have the required amount of volume, and it is having the motor, DC motor, and it is also having the dosing module, and the dosing of urea in the exhaust pipe, and the amount of quantity going to get injected is also very much important. This is how the complete control system diagram looks for a SCR system. And you have a lot of components in the case of SCR. Okay, it is having the AdBlue tank, and it's having the heating power unit, and and again it is having the hoses. You can see the hose, and it's also having the supply module, which is indicated here, and it is having the level sensors to measure the level, and it's also having the dosing module, B clamp, supply line, temperature sensor, and this is temperature sensor, this is the supply line, and this is the module of clamp, and the dosing module, and you also have the SCR catalyst made up of either zeolite or V2O5, and you have the SCR mixer, how it gets mixed, you see here. along with exhaust gas is coming out of the DPF. The exhaust gas along with the urea, it gets mixed here. And you also have the NOx control unit. And finally, you measure how much is the NOx using the NOx sensor. So you have one more technology called NOx trap or LNT. So, but the system efficiency is only between 50 to 70, whereas the efficiency is much more higher in the case of SCR. So you have two type of mode. One is lean mode, another one is rich mode. So NOx storage will happen when the engine is running in lean combustion mode, and when engine is running in rich combustion mode, you get the NOx gets regenerated. And the operating window for this NOx storage is between 150 to 400 degrees Celsius in the case of LNT. And again, even in the case of LNT, you need to have the special coating in the form of substrate with respect to the platinum, rhodium, and you have the barium carbonate as the coating catalyst in the case of NOx trap. So in the case of lean mode, the NOx gets storage, and in the case of rich mode, the NOx gets regenerated. So when lambda is greater than 1, which is nothing but a lean mode, you also use the platinum as the catalyst, and you use the coating called barium carbonate, barium nitrate, and barium sulfate, and you get the oxidation, the process, and NOx gets storage. And what happens when you're going for a regeneration mode? You get nitrogen and CO2 out of the exhaust pipe. This is how the complete LNT looks. You have the system which is completely closed one. The design is much more compact, and it's good for the low exhaust back pressure. The complexity is much more lesser. It's good for the better temperature management system. So it is having the temperature sensor, pressure sensor to measure how much is the pressure, how much is the temperature, because depending upon the temperature, the catalyst performance will also vary, and this will measure how much is the NOx which is coming out of the LNT, and you need to reduce the NOx to the greater extent as per the norms. So now we will see for different vehicle category, what are all the emission regulations that we have, and what are all the emission control technologies that is being followed. So this is with respect to the light duty diesel emission regulation. So with the help of the three-way catalytic converter, you can reduce the emission because of gasoline engine. Yeah, achieving the emission norms in the case of diesel is much more challenging. So we will see the emission reduction technology for light duty, heavy duty, and off highway for the diesel application. So we have the limit between BS4 and BS6. So first we will see what's the change with respect to the BS4 and BS6. So with respect to light duty diesel emission, so you have the total hydrocarbon and NOx, which is indicated in milligram per kilometer, which is 300 milligram per kilometer in the case of BS4, and in the case of BS6, it should be 170. So you see almost the combination of hydrocarbon and NOx is also gets reduced. And looking back to the NOx and the particulate matter, the NOx should be 3 times lesser, and your particulate matter should be 6 times lesser. And there is no change with respect to the carbon monoxide. However, when you're going for onboard diagnostic, you are also ensuring that your carbon monoxide is also going to get reduced, and your overall hydrocarbon and NOx particulate matter is also going to get reduced. So, and again, when comparing to BS4, your durability of the vehicle should also be higher. So 80,000 kilometer is the durability for a BS4 vehicle, and 160,000 kilometer is the durability with respect to the BS6 or Euro 6 norms. So your durability is also going to be higher, and your real driving emission will start in the year 2020. It's almost started now, and it will get implemented year 2023. And the BS6 is going nowadays, and this is the nitrogen oxide emission control technologies in Euro 6 diesel, which has been finalized now. So they are going with different systems like NSC, which is nothing but NOx storage catalyst, which will reduce the nitrogen oxide emission, and CSF is nothing but catalyst soot filter, which is nothing but a DPF. It will reduce the particulate matter. So in the case of NSC and CSF, we use the platinum, palladium, and rhodium catalyst. And this system, NSC system, will also require a fuel addition, and you also have the higher fuel consumption because of NSC. And this is NSC is good for a smaller vehicle, basically for a two-wheeler or a three-wheeler. You can go for this NSC technology. And you have the next system called SCR technology, where you have the regular system DOC, you have CSF, DPF, you have the SCR, where you inject urea. As I said, you have the catalyst like metallic zeolite, vanadium oxide, and this is favored for a larger vehicle and for higher speed vehicle. Basically, for a car application, we can go with the SCR technologies. And you also have the advanced SCR technologies, where the difference is the difference between the normal SCR and advanced SCR system is you add extra ammonia slip catalyst. So, and when you're going for a higher amount of ammonia again, your efficiency conversion will be much more higher, and your NOx reduction will be much more higher. So here in the case of advanced SCR, you have the SCR coating on filter, and it allows the improved thermal management of catalyst on the vehicle. And this is technically very demanding system. And you have the ASC, which is nothing but ammonia slip catalyst, to have the better NOx conversion. So you can also shift towards the advanced SCR from the normal SCR to meet the real driving emission norms. And in future, we also going to have better storage capability using the NSC or the advanced SCR system. It also going to get incorporated along with DOC for the urban control system, as well as to reduce the NOx. So what is the roadmap for Euro 7? Okay, so we have finalized the Euro 6 diesel. From temporary, we gone with the final one, where it is having the DOC, SCR, and ASC technology, which is nothing but advanced SCR technology we have. And after many combination, we are also going to finalize the Euro 7, which will happen in the year 2023 or 24. So here the system remains same. You have the DOC, you have advanced SCR, or you can also go with the SCR with the ammonia slip catalyst. Okay, this is the final configuration which will come, where still you will be reducing the NOx emission, where which you need to increase the quantity of ammonia slip catalyst as well. So real driving emission assessment has been done in USA, in a place called Royston. So the tests were carried out in normal condition and also in harsh condition. So almost 84 kilometers had been covered in a vehicle, covering the city driving condition, rural condition, highway condition, and the percentage of vehicle kilometer is also completed 100% on time with respect to time. And you see the average speed uh, of a normal driving cycle is 51 in the case of combination of city, rural plus highway. So with respect to different average speed, different distance, different kilometer, you need to ensure that you are going to meet the real driving emission for the light duty diesel vehicle, which includes for two-wheeler, three-wheeler, four-wheeler, passenger car, etc. And also you need to do the test, which you need to ensure that you are going to meet new European driving cycle, WLTP cycle, RDE cycle. RDE stands for real driving emission. WLTP stands for worldwide harmonized light duty test procedure, and NEDC stands for New European Driving Cycle. So this evaluation is very much essential to ensure that you are going to meet all the emission along with the fuel consumption and also the durability of the vehicle. And in the case of light duty diesel vehicle, you need to follow the transient test cycle called worldwide harmonized light duty transient cycle. So you are also going to run the test cycle along with the gradient of 1.5 percentage, and this situation is slightly much more worse than the normal driving. And here, what you are going to do is that you are going to run the vehicle in urban condition, rural condition, and also in motorway condition. And when you're going for urban condition, you run the vehicle in a low speed, and when you're going for a rural condition, you run the vehicle either in medium speed and also in high speed. And when you're going for a motorway condition, you run the vehicle in extra high speed. So this is the graph which shows between the time versus speed, and the average speed or the maximum speed is 120 to 140 kilometer when the vehicle is running in motorway, and when the vehicle is running in rural condition, you get the maximum speed of 120 kilometer per hour, and you get 50 kilometer per hour when the vehicle is running in urban condition. So next one is the heavy duty diesel cycle emission regulation and emission control technologies. So heavy duty is also very much important. So we do the testing called the emission in static control and emission in transient control for engine. So here also we need to reduce the emission of hydrocarbon and NOx. So the carbon monoxide emission remains same between Euro 4, Euro 5, and Euro 6. Whereas you need to reduce the hydrocarbon almost 3.5 times, and the NOx close to three times. You need to reduce the NOx and particulate emission 50%. So this is the emission norms for a steady state testing and also for a traction testing. So in the case of heavy duty diesel cycle, so we go with a different combination. Basically, for to achieve Euro 6, we go with DOC plus DPF, which is nothing but coated. It is also called a CSF, coated soot filter. Plus, you have SCR is made up of either iron SCR, copper SCR, or vanadium SCR. You have different strategies even in SCR as well. And of course, you're also going to use ASC along with the SCR. So to go with Euro 6, you have the combination of either vanadium or copper or iron SCR. So whether you need to go for an active or a passive regeneration casing strategy in the case of DPF or SCR or CSF. So and again, whether we need to go for a copper SCR, vanadium SCR, which is the best system to go for it. So this is the system of a BS6 for a high HDD heavy duty diesel vehicle. So you have the comparison between the passive SCR and an active SCR, between the vanadium based SCR and the copper based SCR. Basically, the vanadium based SCR is said to be the passive, and the copper based SCR technology is said to be the active one. When we're going for an active SCR, you have the EGR in it. I have shown you the vehicle with the EGR condition, where you will reduce the NOx in it. And in the case of a passive system, you will not have the EGR, but nowadays mostly they are going with the active only. And in the case of active, you have the in-cylinder or external hydrocarbon doser, and it's also having the DPF active regeneration and also copper SCR to reduce the disulfur oxidation. So in the case of active SCR, it is nothing but a copper-based one. You have the platinum, palladium, and rhodium catalyst here in numbers. And but again, the design is also complex. You have the DOC and the CSF for active regeneration, and you have high performance in the case of copper SCR, and you have selective AAC as well. Whereas in the case of passive SCR, what happens is you can eliminate the AGR, okay, and you can also increase the thermal management by increasing the SCR temperature by between 50 to 100 degrees Celsius, and you have lesser amount of platinum, palladium, and rhodium, and you have lesser one, and this is good for a passive regeneration, and this copper is good for active regeneration. So you need to select depending upon the system what it calls for. And the case of heavy duty diesel HDD, this is meeting the future emission is the toughest challenge. It's not only in India or Europe, but even in other countries as well. For instance, China, they also follow their norms. They follow the different stages of norms, like China stage 3, like we have BS3, BS4, and they also follow China stage 3, China 5, and they also have the China 6. So we are in 2020. So they also in China they implemented they started the China 6 norms. How we have BS6 in India, well, they also gone with BS6 China 6 technology to achieve better NOx and the particulate matter emissions. And the last important thing is the off-road vehicle emission regulation and emission control technologies. So basically the tractor, okay, so that is comes under the off-road technology. So it's also called as a TREM, tractor emission. So we need to go for a TREM 4 in October 2020 in India. And this TREM 4 is applicable for different capacity of the tractor ranging between 75 horsepower or 174 horsepower or 750 horsepower. And in the year 2024 April, India have to go with Bharat stage tractor emission 5. So what is the difference between the emission which is there at present and what is the emission between the TREM 3 or TREM 4 or TREM 5? The major difference is mostly with respect to the hydrocarbon and NOx. So there is no change with respect to the carbon monoxide, but NOx and hydrocarbon is much more very important task to get reduced. And here, in the case of off-road technologies, the technology what had been used is either to go for a DNOx or a filter forcing system. So here we also go with ammonia slip catalyst by going with different combination, and you follow NRTC test cycle to ensure that you are going to meet the emission for off-road test vehicle. So non-road test cycle you need to follow. So what is the difference between on-road and off-road with respect to the legislation point of view? So in the case of on-road, basically called as BS6 or Euro 6. So you have the system calls for DOC, SCR, or DPF, CSF, SCR plus AAC. So what is the difference between the normal vehicle, on-road vehicle and off-road vehicle with respect to the emission is? It is mostly towards introducing the filter forcing. Okay, so by introducing the filter forcing, you are also reducing the particulate number. You are increasing the particulate number, and again you follow different test cycle. You go for a non-road test transition cycle. You go for a non-road steady state condition. You go for a cold test, hot test. But in the case of on-road, you go for a worldwide harmonized light duty and heavy duty transition cycle, steady state condition cycle. So the amount of ammonia injecting is lesser in the case of on-road, and amount of ammonia you are going to induce in the case of the off-highway is much more higher. And again, the durability is also very much important, where you term in term of kilometer, where in the case of BS4 it is 80,000 kilometer. In the case of BS6 you need to go with 160,000 kilometer. And when you're going with a system of off highway, you call that in hours. So you should have 8,000 hours as a durability when the vehicle is greater than 37 kilowatt hour. So now in the year 2020 October, we are very near to it now. In India, we will be going with tractor emission 4, and after 3 years, we will be going with tractor emission 5 as well. There is no change with respect to the NOx, but the particulate matter emission is much more significant. So this is the different configuration that you have. Either you can go with diesel oxidation catalyst alone, or you can go with diesel oxidation catalyst plus filter design. So this is for the vehicle ranging between 50 to 75 horsepower. So you can go either with platinum or palladium. It can be either, the filter can be either partial or full. So Trump 4 will be launched in October 2020 for Indian technology. So again, we have Trump 5, which will come in the year April 2024 for India. So this is also applicable for the tractor capacity ranging between 75 to 750 horsepower. So you have both active system and also passive system. So in the case of active system, you go with the platinum palladium zone, and in the case of passive system, you go with only platinum zone. And this is the one for DOC, and in the case of DPF or CSF, we have platinum plus palladium, and you also have the combination of SAC, silicon carbide or chloride, and the SCR system. You have the vanadium based SCR, which can be coated or extruded, or even you can go for a copper SCR as well. And you have the ASC, which is nothing but ammonia slip catalyst. It's bound with SCR or standalone system. So this is the system of configuration of SCR technology. You have two configuration, SCR-T and SCR-F configuration. So in the case of SCR-T, you go with DOC plus CSF plus SCR plus AAC design. Whereas in the case of SCR-F, which is the advanced version, where you have again you have SCR plus SCR AAC, the amount of ammonia is much more higher. So DEF stands for diesel exhaust free air. Diesel is which is coming out of the first stage from DOC CSF, and again when it is go to the SCR, your particulate matter gets reduced here, and when the exhaust is coming here, your NOx also gets reduced. So there is a difference between SCR, the basic technology, and advanced technology. With respect to NOx activity, is almost similar. So what is the advantage when you're going with advanced technology is that you get 20 to 40% reduction of filter and volume gets reduced. And even this advanced technology is better for higher temperature. And again, this will also allow for earlier injection as well. And there is a potential for early urea injection as well in the case of advanced technology of ACR. And in the case of normal base version, it's better for the passive soot oxidation. And with respect to the back pressure, the basic technology of SCR has typically the lower system back pressure drop than the advanced, because it has the lesser volume, the back pressure is also on the higher side. So apart from the SCR, DPF, DOC, what is very important is that you need to look for an alternative to reduce the emission in an engine, basically in internal combustion engine. So the best way is to look for the biodiesel or a CNG or LPG or LNG or ethanol or methanol. So which are the primary source which acts as a fuel, either in the form of liquid or a gas. So the biodiesel is nowadays being used as in many forms, and you get the biodiesel using the trans-esterification process. You can go with either soybean oil, or you can go with neem oil, jet oil, where you mix or blend this soybean oil along with diesel with a different combination, 5% of oil and 95% diesel. So when you are increasing the percentage, your nitrogen oxide emission, smoke comes down. And you can also do some modification in the engine by adjusting the injection pressure to have a better emission and also better thermal efficiency. And you can also go with the CNG method. Nowadays, what we are using is we are also going with the ethanol-based gasoline fuel, which are being used. And ethanol is made up out of corn or grains or from agriculture waste. And LNG you can use for a cryogenic engine. And LPG, most of the Maruti vehicle they are using the LPG technology. And methanol is also much more widely used. And the blending B20 stands for 20 percentage of the biodiesel and 80 percentage of the diesel. You can go with this combination, blending combination. And you can nowadays the CNG is also used in many type of vehicle, and we are going with the electric vehicle to reduce the emissions. And ethanol, E85 combination along with 15 percentage of gasoline is used in many of the light duty vehicles, medium and heavy duty trucks as well. And here they go with 85 E85 ethanol and gasoline, or a combination of both gasoline and also ethanol. The only problem is the ethanol is having the corrosive structure, corrosive nature, so the corrosion of the engine components will happen. But nowadays the testing had been done to ensure that the corrosion is not going to affect the engine parts. So the next alternate fuel what we have is the hydrogen. And the only problem is that we don't have any vehicle which are commercially viable, but some vehicles are being leased for demonstration purpose only. Because of the safety, this is not been introduced. And you have LNG, LPG, and also the methanol-based vehicle for some of the heavy-duty buses we are using with methanol M85 combination. And some of the light-duty vehicles, the passenger car run with the propane or a gasoline medium application. And even some of the heavy-duty trucks and buses also run with LPG technology. And the medium and the heavy duty trucks and buses are being used for a liquefied natural gas application. So the advantages what we have with respect to the biodiesel is it is renewable, it is energy efficient, it displaces the petroleum derived fuel, diesel fuel basically. And this also ensures that it's good for going with only minor modification in an engine. And it will also reduce the global warming, and it will also reduce the tailpipe emission. And this vegetable oil, the biodiesel is non-toxic, biodegradable, and it's suitable for a sensitive environment. And it is also made up out of the agriculture and also recycled resources. Let us all pledge to reduce the emission. Wishing you all the best for a bright present and future career. Thank you for an opportunity. Please email me at p.arjunraj@gmail.com. I look forward to have a very good interaction with all of you. And this is not an end and just a beginning. We have just kept our leg in the sea, still milestone for us to come to stream. Please contact me at p.arjunraj@gmail.com. Thank you.